Hello, and thank you for joining us on our application video for polymers. Polymers are ubiquitous in our daily life from containers, packaging, and children's toys. The composition of polymers and what quantity of additives are present are important to know from a quality and formulations perspective, as well as a health and safety viewpoint. Traditional polymer extractions can be time-consuming and difficult due to the robust nature of polymers. The EDGE provides a vastly improved method for extraction that is both quicker and simpler. The EDGE provides consistent and even heating as well as inline filtration of extracts. Let's now walk through programming the method on the EDGE. We first name our method and select the QDIS that we will use. In the parameters, we first set the solvent. We will program in our addition, per our application note, with 20 ml top add. The method has a set temperature of 80 degrees Celsius. Temperature is of the utmost importance for polymer extracts and may need to be fine-tuned for your extraction. The hold time is going to be 15 minutes at temperature. The long hold time is needed for solvent penetration within the sample itself. Lastly, we are going to program the wash. Like the cycles in the method, the user has full control of the wash parameters as well. A wash is done after every sample to ensure a clean, fluidic pathway. Next, for sample prep, the first thing we're going to do is assemble the sample holder, the Q-cup. The first thing to do is to place Q-disc into our Q-cup base. The Q-disc is the inline filter we have for the Q-cup. We will be using the S1 stack, which consists of a glass fiber filter supported by two cellulose filters. This Q-disc has a porosity of 0.3 microns, which is suitable for any kind of analysis. We then assemble the Q-cup by screwing together the body and the base. The single thread design makes it simple to assemble and clean. For polymer samples, we recommend increasing the surface area of the sample. Tubes or sheets of plastic can be cut down to size to fit inside the Q-cup. For pellets, this may involve cryo-grinding. We will now weigh the sample into the Q-cup. The Q-cup is made of lightweight and hard anodized aluminum, so it can be placed directly onto an analytical balance. At this point, any internal standards or surrogates can be spiked into the Q-cup as well. Insert a Q-screen into the opening of the Q-cup and push it down with the Q-screen tool. This screen helps to keep the sample submerged in solvent and keeps the inside of the sample chamber clean. Now, the Q-cup is ready to be placed in the rack along with the collection vial. Today we are using the amber 40 ml glass collection vials. With our sample in the rack, let's go ahead and load the rack into the EDGE. The rack is held down by magnets, which lock it into position. Select the method we programmed and load it into the position. Press play, start, and let the EDGE run. The automation will load the Q-cup into the sample chamber in the rear. The autosampler will then move into the collection position above the vial as the seal head comes down to close the chamber. The seal head then adds solvent, and the heater heats the chamber and the sample to the programmed temperature. From then, the unit holds until the program time is elapsed. After the program time has elapsed, the EDGE will then collect the extract. After the initial collection, the EDGE then purges the sample with the built-in pump. After the purge, the EDGE then removes the sample from the chamber. Places it into the original position, and then moves to the wash port to begin its wash. The extract has been filtered and cooled. The extract is ready for you to bring to volume. We can now transfer the extract to our Q-Dry to evaporate the extract to dryness. We reconstitute the extract in isopropanol and transfer to LC vial. We will now load the LC vial and run an appropriate LC-MS method. In a short while, we will have our analytical data and will be able to calculate our percent recovery. Acceptable recoveries and RSD values were obtained. Thank you for viewing our virtual application note for additives in polymers. For more information and to access the actual application note, please visit cem.com.